Alright, time for another draftphysics.com, debatephysics.com, also video presentation. These are really important and interesting subjects. It really is disappointing that people are just so closed-minded, so religious, frankly. They just live in bullshit. And it's just very tragic. So anyway, the Dispar character, desperate character, just keeps doing shit experiments, and this one's just so bad. And so he's back to swinging a pendulum, okay, because I pointed out that you can't do this subtraction thing where you pretend the gravitational mass will be part of an impulse mass, because it really won't. An impact by impulse happening fast, there's no time for gravity to happen. Gravity takes time. That's why things weigh less when they move very fast across a surface. They weigh per inch less and less because there isn't enough time for gravity to give them weight. Anyway, so he doesn't like these facts. Okay, facts he can't dispute with any theory or any evidence or anything. He just doesn't like that there's facts in his way. All right, so he's trying to prove that 1 pound, that one mass going 2v isn't the same as a 2 mass going 1v. And in this experiment, he's doing a really poor job of it, frankly, because he's basically proving the opposite. And this is in the context, remember, where Brozo was promising to redo the lever launcher experiment, which tests the very same thing. And he was going to prove that he was going to get that old 1.4 result, that the same energy can only produce a half mass at 1.4 the velocity, not twice the velocity, only 1.4. But no, that never happened because he couldn't make it happen. So as much as they try to cheat, they just can't. They can't find a way to do it first that actually works. So in this case, he does this experiment and he concedes the ruler moved. So right away you're like, what the fuck? What are you doing the experiment for if the ruler's moving? So obviously you do have to move the ruler, okay, and obviously the numbers completely change, which means the numbers almost become the same number here in this case, because you moved this ruler where the 14.8 happens. Well, you move it, okay, in that direction, getting closer to the 13 point something. So this is the one mass. Okay, I do it this way because my mouse doesn't always show up. For whatever reason. I gotta fix that, I guess. So this is the 1 mass going 2v. This is the 2 mass going 1v. Obviously, I would claim it's the same momentum. It's therefore the same capacity to do work. Blah, 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 blah. Now, he's getting a number 13.7 and 18.5. And instead of giving us just what the displacement number is, he gives us these stupid numbers, which are useless in this case, because the ruler moved. So, as you can see, the 17 mark is on the way out here, over here, and it's way in here, over here. So, obviously, way out of whack. And again, if you move the ruler in the direction, okay, if you move this ruler that way, well, then this number is going to be much higher, 14 point something. And obviously, if you move this ruler over that way, this would be a 13 point something. So, very close to the same. The weird part is, this ruler is obviously smaller than this ruler. Yet the background, this part of the background is much smaller. So we have a bigger ruler and a smaller piece of background. You can see this green section is much smaller over here. But if you look, the proportions are rather similar. That is, the amount of green to black is comparable. And black to white here of this background. Now, he could have done this experiment by, extending this board in the back, this here, having it go across. Well, you can't have it go across at the top above the rubber band. have a background, and then he could cast a light on it, and he could actually write the ruler on the background, and the shadow should be exactly the same. But he doesn't even mount the camera so it can't move. That the camera's guaranteed to be in the same position, and that's what I think happened here. I don't know. I mean, I don't know how the ruler's perspective got so out of whack. So something, obviously, the proportions are way off. Now, the camera itself does okayish slow motion, but it's garbage lens. It's a whatever you call that, wide view, and it creates insane amount of parallax. You don't even see it. See, in this image, in this side, you don't see nearly as much of it as you see in this side. So it's all part of the shenanigans. So anyway, the results end up being these two are very close to exactly the same energy. So he's basically proving my argument with this shitty experiment where he's attempting to claim something else. I didn't even watch the end of the video because all you have to do is watch this and say, what the fuck is this? You're going to give me data that I can't put these two images on top of each other. They're not under the same circumstance. So what the fuck? And these are shitty this is not good science. This is the way you do bad science. Cheaty, rotten propaganda science. Okay, so now we'll move on to a silly Falwell argument, which has, well, they all have an interesting angle, but it's more theory that is interesting in this case, and so I'll get back to that because this is an argument I've been making for a long time that gravity is basically just giving something momentum, and the fact is it's that simple. The amount of force is always the same, so you could argue that the speed being the same means the rate at which all things fall in gravity means that their same speed will also do something to it horizontally. If I move an elephant at 1 mile an hour, the claim is it weighs elephant, thousands of pounds. And if I move a mouse, it will just weigh, at 1 mile an hour, it'll weigh, whatever, 10, 12, 15 ounces, or whatever the weight of a mouse is. What the hell is that? Where the hell is the arrow? Oh, it's way down here. Okay, so I don't think I'll need that. What do I want to change? Yeah, I want to go to Falwell's page. Okay. So, go there. So he's made this some fucking stupid video where he's defending his shitty experiments and called it coward. And, I'm not going to play it. I'm not going to deal with these fucking shit arguments these shit fuckers make. They can't make a physics argument. All they can do is these antics. So, not interested. But I will argue what took place in his own experiment, and that obviously something's amiss. Alright, so we'll get rid of that. We have our drawing tablet. How nice. Is it focused? No. There's always something. Always something. Alright, that should be better. I have to go get my data. Alright, so in his experiment, he's dropping a very heavy mass, something 25 times heavier, so 725 grams, a tiny distance, 4 centimeters, and then he's going to drop 30 grams, 25 times less mass, from 100 centimeters. And, he's claiming those two things are the same? No, they're not the same. Anywhere close. Can't be, really, frankly. Alright, so what's observed is, my point is that you drop something from 1 centimeter, alright, it doubles its weight. And if you drop it from 4 centimeters, it would quadruple its weight. Now that's exactly what he found for the heavy mass. So the heavy mass, we don't have where he dropped it from 1 centimeter. We only have where he dropped it from 4 centimeters. So, but the point is the 4 centimeter mark, which was almost 39, is exactly what you'd expect, because the original mass moved at 10 millimeters. So if the spring was a scale that was accurate, it would go, 20 for twice the weight, 30 for 3 times, and 40 for 4 times the weight. So it basically confirmed the 40 would be 3,900 grams, which would be 4 times 750. So it's exactly following my argument that a 1 centimeter drop, doubles 2x your mass, all right, and a 4 centimeter drop means twice that number, all right, which is 4 times your mass. Okay, and there's no added, nothing else is added. There, sort of can see that. All right, so it's perfectly fitting that model, and frankly, it's a model, so, regardless, you're saying these two things really should follow the same rule. And the argument is of course, they can't be. Okay, because if this 30 grams, was following the same rule, then at 1 centimeter be 60, and at 4 centimeters be 120, and at 16 centimeters be 240, at 64 centimeters be 480, and at 100 centimeters, it couldn't possibly be 2,900 because it's only somewhere between 480 and 960. Now, obviously, the number is going to be something like 525 or something. So, anyway, he got a number like 29. Okay, so in here. So, it's from 100 centimeters, he's got it weighing, which has to be well over 1,700 grams. And it can't possibly have weighed 1,700 grams. So, it's just ridiculous. The two aren't following the same model. Now, there's a clip from his video I can show you, but I don't know if it's worth the effort. Well, maybe I'll go find that. I mean, where he's actually doing a test of showing the testing of the machinery, and the one mass, the light mass, the 30 gram mass, doesn't bounce back up. It doesn't bounce back up. So, I mean, you're just starting with, you mean it went down, it didn't come back up? Well, something must have got stuck. The spring must have gone inside the object. Something must have happened to make it stick, because it didn't bounce back up. So, I'm not going to bother playing it, because it's all garbage. I mean, these are things other people could detect, and they don't bother. Nobody's applying any kind of rational scrutiny to these experiments, quote unquote, in terms of challenging them to, do a real experiment. The very fact that he's using a spring that isn't tied down, okay, and that it has its little thing sticking up, where it doesn't even have a flat end. Okay, it has the little sticking up bits. So it's not a perfect way to be doing scale experiments. Now, the simple truth is they could just do the simple experiment. They could just take one of their springs, all right, and just put masses on it. Okay, put a 1 mass, then increase it to 2 mass, and then increase it to 3 mass, and see if their spring actually works as a scale. But they won't even do that. But certainly they could do that drop test of just, drop it from 1 centimeter, drop it from 4 centimeters, drop it from 16 centimeters, and see if you keep doubling the mass. Okay, which with every increase of 4 times the distance. But no, they won't bother doing that. Because like I said, the heavy mass followed it perfectly. And so what happened with that lighter mass? And like I said, you can make the argument that what happened was something's fishy. That's what happened. So anyway, it's just like I said, it's just crazy for them to think that this 30 mass just going 5 times the velocity is going to equal a 25 mass going 1 velocity. Hugely different momentums. And there's just no chance they're going to do the same work. Like I said, momentum wins in every contest. Momentum moves spaceships. Undeniable fact. Calculate the kinetic energy of the exhaust, and you'll get a number. Calculate the momentum of the exhaust, you'll get another number. The only number that's going to move the spaceship in the opposite direction is the momentum. in every single ballistic pendulum experiment ever conducted, okay, it always conserves the momentum and always throws away most of, and in the case of a bullet, for example, 99.94% of the kinetic energy doesn't go into the pendulum, doesn't swing it, can't be converted into usable work. So they keep saying the kinetic energy does work, and it fails to do work in every single experiment. And then you could just go to the Mythbusters, crashing a car at 50 miles an hour, crashing a car at 100 miles an hour. No evidence that the kinetic energy did work on the car. Perfect evidence that momentum did work on the car. Twice the momentum, twice the crushing. Twice, 4 times the kinetic energy, twice the crushing. Kinetic energy doesn't get realized again. So in every single case it fails, and then something as simple as a lever, they say, fails to conserve momentum. I can put a 1 mass going 1.4 velocity in this side, and I can expect to move. I can expect to make free momentum. I can expect to move a 2 mass at 1 velocity. So I can make free momentum with their theory, with a lever. So they haven't responded to any of these arguments. They haven't pointed out how, yes, that makes perfectly good sense. I put a 1 mass going 1.4 velocity, and I get a 2 mass going 1 velocity, and make free momentum. So really, I shouldn't have to say anything more. But anyway, to sit there and argue that somehow his crappy experiments are proof of anything is... yeah, whatever. It's obnoxious. That's what it is. Yeah, it's crap. Because they're not done very well. And then in the context of where they run away from the arguments, to call somebody else a coward when they're the ones who run away from every one of these counter arguments. I mean, I made them over and over again. The lever argument, the ballistic pendulum, the rocket argument, the thin ice argument. None of those arguments have been debunked by them in any manner whatsoever. Falwell did a moronic video where he was trying to claim pulleys don't conserve momentum, when obviously he perverted the argument entirely. And in the very end, he pointed out exactly the truth, which is, yeah, they have to conserve momentum. You know, if you move the rope on one side at twice the velocity, and there's a heavier mass on the inside, twice the mass, it's going to move at 1 velocity. The end. It's going to, pulleys conserve momentum, levers conserve momentum. Undeniable truth. And they're going to try to deny it and try to prove otherwise with these shenanigan experiments. And it's just a terrible waste of time, frankly. So just explain why you won't use your springs that you're saying are good measurement devices. Why won't you, okay, just incrementally increase the energy you're putting in and show how it works? Show us all how it works. All right. So enough of a video, I believe, and keep it short and simple and all that crap. And yeah, there's lots of distractions lately, so maybe fewer videos. We'll see what I can get to. So till the next time, and such and so forth and whatnot.